This educational video is based on my latest book and my lectures at William Paterson University. The book is titled The Bad and Ugly: 8 Critical Risks to Funding Your Retirement. And hi, I'm Joe Zingone, the Realistic Economist. What we're going to do today is talk about the 8 risks. We're actually going to talk about one of the 8 risks, but the total of the 8 risks are: it's systematic risk, sequence of returns, longevity and inflation, health and healthcare costs, mitigating taxes, phantom wealth, asset allocation versus product allocation, and unknown unknowns. But today, for this particular course, we're going to look at the sequence of returns, the effect on retirement. A lot of folks will ask me, or I'll ask the question, what makes a sequence of returns so harmful? It's basically an anomaly. What happens is simply this: many folks are not aware or don't understand that there are risks in retirement that exist only when taking money out of a portfolio or out of your savings, and it does not exist when they are in the accumulation phase of putting money into their savings. One of the people that came into one of the programs at the university, it was a couple. They were age 64, and they had said, we want to retire in about a year when we're 65. So what I did is we did a little chart, and we showed them age 65, as you can see with the blue arrow, all the way down to 94, which is 30 years, because they felt for whatever reason, one of the two would make it 30 years. So they just want to see for a full 30 years how they can do with retirement income. Now, obviously, how much could they take out, or whatever they were concerned that they wanted to take out an income every year of about 5% of their portfolio value. And then, as you can see in the numbers, the first year at age 65, it was $12,500. The second year, it was $12,875, and on and on and on it went up. If one of them were still alive in the 94th, at their 94th birthday, there would be a check would come out, would be $29,457. Now, they understood that as time went on, they had to increase that number. That's why you see the numbers go up. And they were looking at a 3% inflation increase. They wanted to kind of stay, keep pace with inflation, keep their living costs, similar. They didn't want to, increase their living lifestyle, but they just want to make sure they had enough to keep the same standard of living they did when they retired. Now, what's important is that any future projection is going to show an investment return. What I did here, we picked some numbers at random form, and you can see that in the first year it's highlighted with the blue. It's 16.6%, then 7.4%, then 12.0%, on and on through the years. And you'd notice there at age 79 there was a 3.2% reduction. Now, the nice thing about this investment is out of those 30 years, there were only 5 bad years that are highlighted by the red arrows that were negatives. And in this case, fortunately, the negatives came toward the end. But if you look at all the numbers and average them out, you can see it is a 7% return. Now, what this is going to do is give you hypothetical numbers, but let's put dollars to those numbers and see what it looks like. What we did here, the couple had started with about $250,000, and as you can see in the first year they took out the $12,500. But this is what makes this portfolio so exciting. It had a great return the first year. They can see that their money was actually going up. Different than, obviously, they knew they were taking money out. They expected it to stay the same or go down. But in this case, the portfolio is actually growing. So they really made a very good investment choice. They've got this 7% average return. They actually, if you go down the list, you'll see that they made a fairly substantial profit. If one of them is alive at 94, you'll see that there's a total of $712,000 in that account. So what's interesting is this: the sequence of returns really determine what dollars are in that account or what's left. So what we're going to do is this: We don't know when the good years are going to be or when the bad years are going to be, or even for that matter, how long they're going to be bad years or how many years will be good out of those. We just don't know. We're subject to all, we're all subject to randomness. We have no idea where the market's going to be tomorrow, despite our best investment advice out there. Hypothetical return, you're going to see what happens through all those years, which we can do. But let's do something interesting. Let's flip those returns. So what we're going to do is take the return that we've gotten the first year in the hypothetical annual return, and we're going to bring it and make it the last year's return. And exact opposite, we're going to take the last year's return in 94, which is at minus 17.6, and bring it into the first year of our new model. So what we did basically simply is we took our returns, exactly flipped them, so the first year became the last year and the last year became the first year. Now we can jumble the numbers up because we don't know, again, we're all subject to randomness, but I want to show you the difference in what a sequence of return makes on an account. Now, just so you know, the average of the new scenario was still 7%. That does not change. So what you can do is write down this rule or memorize this rule. The order of returns doesn't make a difference during the accumulation stage. The ending balance will always be the same. However, everything changes when you're taking money out of your portfolio. So what we're saying is this: you got a 65-year-old couple. They now want to enjoy a little bit of their savings. They say, hey, look, we worked most of our lives. We want to take a little of this money out because we want to or we need to. And that's going to help them maintain their lifestyle. As you look at the columns, you're going to see something extremely interesting. What happens here is they're actually run out of money. As you see in those first years, $193,000, they're taking the same money out as they were before. The difference is that this account is slowly dropping. What really made the difference is the sequence of their returns. We put those bad 3 years in the beginning, and we put the good years, the better years at the end. So the sequence of these returns, again, we don't know where they're going to be, how they're going to be, in what order they're going to be. We just know that the same number, still a 7% average, could be very, very different amounts of money and very different outcomes. So if you look here, you'll see those first 3 years, we had some bad years in there. It was 17, 12, and 3. Those were bad years, but you spoke to your broker, your advisor, and he said, look, you're in the market for the long term. The market's going to come back, and market always comes back. And he was correct. And you'll see in the next 3 years, the market did come back, and it came back fairly strongly with the 6% and 8% and a 15% return. But if you look to the column to the right, these increases in returns were not enough to really bring this portfolio back to where it was before with a better set of numbers. So if you look a little bit further, you'll see in the, I guess that's year 6 or year 7, there was a small little hiccup in the market. It dropped a 3% return, but the market came back strong for the next, I guess that's 7 years or so, or 8 years. And what happened? You got a 7%, a 16.9%, a 7%, 11, a 12, and an 8, and whatever. So what's happening here is the market really kind of kicked into overdrive, got some great returns. But if you look at the column to the right of it, you'll see that the numbers are not going up because there's not enough in that account to really take advantage of this market growth. As you look again, you'll see in year 30, in year, I guess it's age 80, you'll see another hiccup again at minus 3.2%. But what's happening, if you look at the ones in the circle or the oval, there's a huge amount of stress that's going on with these couple. If you can ever think of like an analogy or a story, if you're running low on gas and you're in a very unfamiliar area, maybe a different state, you kind of tend to focusing on that gas gauge. You're looking every few seconds or so. you're not really enjoying your trip or concentrating where you're going. Your eyes are focused on the gas gauge. So what we found with a lot of folks is that when you have this portfolio, especially in the early years, it kind of has a few bad little hiccups in there. It really puts a huge damper, because as you see your balance going down, it's a huge amount of stress on, am I going to have enough? Is there going to be enough for my spouse, if you have one, for her to live on? So this particular slide is showing the same thing, 7% average return, but a hugely different result. I'm going to try and give you one piece of investment advice, and this will probably be the best advice you'll ever get. If you can, always choose the early positive returns. Basically, it works out much better. You have tremendous amounts of more money in there. You don't really have to worry about running out, as contrast to your not so good choice with you running out of money. Now, when you look at the two numbers, the two sets of numbers, the randomness in there, you're looking at an account value that could be $634,000, or under the scenario where we don't know the sequence of returns, could be about a little under $18,000. That is a huge difference, and it makes planning for retirement very difficult, if not impossible. Where are you going to be? Are you going to be at 634? You're going to be at 17,000, somewhere in the middle, or worst case scenario, you're at age 82, you're totally completely out of money. So what we're going to learn here is simply this. Average returns do not matter in the accumulation part. So for when you're accumulating money, average returns do not make a difference. But here's the problem that we all, that a lot of folks face. Every advisor and every forecasting program uses average returns to show you numbers. In other words, what dollars are you going to have based on a withdrawal rate? So they're using average, but we just saw that average returns can mean different things to different people, different things at different times, because we don't know what sequence these average returns are going to happen. So what we want to do is, why does this happen? Why would they show you average returns when they know average returns could mean it could never be anything close to average, or it can be higher or lower? So what we found is that when you show average returns, like in the example, it looks much better on paper. And more folks are inclined to keep their money with them, their advisors, and hope that the average returns really mean something. But as we learned, they really mean very much. So here's what you're going to see. They're going to take you through a simulation. They say, okay, folks, you're going to put in some money. You're going to take out your 12% per year. I'm sorry, your $12,500. We're going to annually increase that by 3% or inflation rate. And based on hypothetical average returns, these are the numbers that you're going to have. So you basically see your account starting at $250, goes to $279, and at the end, at age 94, it's $712,000. But the problem that they don't tell you is, because we're subject to randomness, we have no idea when the good or bad years are actually going to fall. We can project an average, and as we learned, average really doesn't mean much, but it gives you a sense of, when you see it on paper, it becomes a little bit more real and a little bit more fact. Mean very much. So here's what you're going to see. They're going to take you through a simulation. They say, okay, folks, you're going to put in some money. You're going to take out your 12% per year. I'm sorry, your $12,500. We're going to annually increase that by 3% or inflation rate. And based on hypothetical average returns, these are the numbers that you're going to have. So you basically see your account starting at $250, goes to $279, and at the end, at age 94, it's $712,000. But the problem that they don't tell you is, because we're subject to randomness, we have no idea when the good or bad years are actually going to fall. We can project an average, and as we learned, the average really doesn't mean much, but it gives you a sense of when you see it on paper, it becomes a little bit more real and a little bit more factual. So getting away from the hypothetical, let's look at some real historical returns of what happened to a couple if they retired on January 1st of any of the 52 years between 1926 and 1978. Now, the reason I picked 1978 as the last year is pretty important, and the reason, if we show 30 years, 1978 takes us to 2008, and if you're all aware of what happened in 2008, we had a big black swan. The market took a nosedive. So we're going to show you everything up to, but not including that anomaly or that problem in the market, so you're going to get a little bit more realistic view of what would have happened had any of these people retired. So let's take a look. And what we're going to see here is a chart, if you can look closely on the bottom, there's some numbers. It says 26, 27, 28. That's actually 1926, 1927, 1928. And if you look at the column that's going up, you see 65, 70, 75, 80, and beyond. That's to show you the years in retirement. Now, what's important? These are actual historical returns if somebody retired on January 1st of that year and they had an 80-20 asset mix, 5% withdrawal, and a 3% inflation. If they had $1 million, what will happen is simply this. These blue bars, I think there's about 16 or 17 of them, that's where the folks did not run out of money. In other words, whatever they had in that account, it could have been $1, it could have been hundreds of thousands. We just know that they did not run out of money. Now, if you take a look, and you're going to see something pretty profound, all these red lines that are coming up are showing you all the times the account did not last. In other words, they ran out of money. They didn't make the 30-year time span. What happened is simple. Because we don't know we don't know the sequence of returns, we have no idea how to project what the values are going to be on the accounts. But looking at these, we're actually looking at real numbers of what happened in the market over those 52 years. And we found out a great majority of the time the folks didn't make it. In this case, we're looking at, if you see the highlighted line that says 75, we know for a fact in these past 52 years, or the 52 years being illustrated, that 100% of the time the folks did not run out of money. So if they lived to 75 and died, they would have never run on any of those scenarios or have run out of money. But when we extend it, when we talk about a little bit more longevity, we take it to age 85, what we see is a 38% failure rate. If we go to age 90, we're looking at a 53% failure rate. And if we run it out for the full 30 years, we're looking at a 66% failure rate, which simply means that most of the time, if you're looking for longevity, you're seeing a lot of folks not make it until the end of their life. They've kind of run out of money before they run out of life. When using the floor of averages, let's use, in this case, real life historical numbers and not just hypothetical numbers. We're going to look at 3 generations: Grandpa, his son, and his grandson. They all had a similar amount of money, and they're all going to retire at different times. This is going to show what a normal distribution curve or a line would be if you had an investment and it did an average return based over those 30-year period that we're using in the example. This particular case started with $100,000. As you can see with the arrow around age 80-ish, it starts to peak. Then it starts to decline as life expectancy gets into the 30-year mark. So by looking at this curve, you would assume that your money should last, if you had $1 million portfolio, it should last at least to 30 years. What we're going to do is plop Grandpa right into a retirement. And we're saying that he retired on January 1st of 1929. And if you look at the red line, that's showing that same distribution curve that the money should last. But in actuality, the dark line with the box is showing that he ran out of money by the time he was just, I guess, about 74 years old. Now, let's look at the son. The son becomes broke after 13 years. Now, we're using true historical numbers. If he retired on January 1st of 1966, as you can see there, the money didn't make probably, I guess that's about 77-ish or so, 77, 78 maybe. At that point, he was broke as well. So what happened? The red line is still there, but it's showing an actual happening with the true returns that he retired on January 66. Now, let's look at the grandson. The grandson is broke in 12 years. If he retired on January 1st of 2000, again, that red line is showing the distribution curve, that the money should last a lifetime. But in this case, he's broke in 12 years. By 2011, he has run out of money. As we reviewed, both of the prior examples that we've just looked at really don't leave you in a very good situation. So let's just do a quick summary. As you'll see here, you've got to understand you really can't use average returns in projecting how long your money will last. I just want you to understand, never ever can you use average returns. Average returns are used all the time in retirement projections, so that causes a lot of problems. We know we can't use averages, but every time you get these projections, they're using average returns. So what I want to tell you is that these results that you get out of those numbers are worthless to use for income planning. And we don't know what our sequence of returns will be. Remember, randomness rules. And here's the problem. Most people want a sure thing instead of a maybe. So as we go through these particular programs, this is going to conclude the section on sequence of return, which is one of the 8 risks that we initially talked about. In future videos, I'll review the remaining 7 risks and present some solutions how to avoid these risks in retirement. If you need to, you may contact me at joe@realisticeconomist.us. Or you can visit my website. It's www.realisticeconomist.us. Thank you very much. Have a great day. Goodbye.